it's already gone too. So, hello everybody. Welcome once again to one of what?
That's one way to say it, celebrating.
That was Pradeep with an echo. He looked at YouTube if YouTube is working, and I guess this.
Oh, I was so
just go ahead. Yeah, just
yeah.
go ahead.
Okay.
Inception.
Yeah. Confusion. Okay, take two. Hello everybody, and once again welcome to Jina's Engineering All Hands. Today we're joined by Florian. He's going to be talking about how to migrate from 1.x to 2.x, or specifically upcoming 2.0 release. So first of all, for anyone new here, what is Engineering All Hands? It's a summary of what's going on. We share our goals and milestones. We do a bit of show and tell. We give tips and advice. We answer all of your questions, and we're always super open to the community. It's the second Tuesday of every month, 2 p.m. to 3:30 p.m. right here on Zoom. A quick update from what's happening at Jina. We have launched the Jina 2.0 meme competition. So you can submit your memes all about Jina, your experience running it, how 1.x compares to 2.0, and we're going to select a bunch of winners at the end of the month. The winners get very cool Jina swag, and the top 3 get exclusive, personalized, 3D printed medals made out of only the finest cheap plastic we can find. Later in the month, we've also got the Are You Hacking Hackathon being run with MLH, and there are prizes to be won there as well. So here are a few of the entrants to our meme competition. So some of them from internal, some of them from external users. And if you want to enter, go to jina.ai/blog, and it's the most current blog post on there about the meme competition. All right, so let's move straight on into the presentation. It's going to be led by Florian with assistance/interruptions from Max. And yeah, Florian, do you want to go ahead and share your screen?
I think you're muted, Florian.
Yes, I think so too. Thanks for reminding. Yeah, hello world. We would like to, we're actually a bit proud to present you today, possible migrations from 1.x to 2.0. We converted a couple of examples and client cases to 2.0, and we found it relatively easy to do, and would like to share you our experience with this and get you inspired. And so yeah, first we will tell you a bit about the 2.0 in general. So like not everything changed, but we describe you what 2.0 is, and recall a bit on this. And then we tell you what changes we introduced from 1.x to 2.0, give you an example to make it easier to understand what these changes really mean, and then talk just a bit about dependencies, how we manage them. And yeah, first, introducing 2.0. We have documents. Document can be any kind of data point. And we have attributes for these documents, which wrap our important data. So like these attributes here, buffer blob text, but also meta attributes like ID, which are not actually the data, but this are necessary to describe the data. And then we have recursive attributes like chunks and matches, which are document lists itself. And we have attributes like the relevance score and evaluations, which are important when you have a ranker and you want to calculate the match, the relevance of possible matches. Then you assign these score values. Also, when you do evaluation and have some evaluation matrix, then you can set these evaluations attributes for this. And here's an example where we create a document. So it's really just as you used from Python, creating this object, setting an attribute, and done. And similar way, you can also drop an attribute. So sometimes when you store documents, you don't want to store all the data. So you, after processing, for instance, the images, you maybe just want to drop the images, or in this case, the text, because you don't use them anymore in the preceding steps. This text, URI, buffer, blob, it's actually one attribute, content attribute. It means only one of these document attributes can set at a given time. So think of it like if you have an image, you want to represent this image as ND array, for instance. It just doesn't make sense to have it stored as a buffer at the same time, because this costs more memory. And we get this conversion functions where we can convert a document from buffer, for instance, to blob, or from URI. So think of you have your data at a cloud storage bucket somewhere, and you just specify the URI, when the URL of this document when you initially insert the data into your flow. And then it's at any point you can convert it back to a buffer, for instance, or to a blob to actually process on this data. So very handy, this conversion. Here you see the red lines. These are conversions we made specifically for images. So for instance, the buffer to ND array. This is a typical operation you do on images. And previously in 1.x, this was handled by drivers. And drivers are very hard to find, hard to explore. And you didn't know sometimes what driver you're using. And now you know this interface of the document and know what know all the functions you could possibly call. And then just from the name, you can realize what's the function you actually need. Then, yeah, similar to 1.x, we have the same document structure here, just to recall for you to have this in mind, how this actually works. We have this root level, root document, and it can consist of chunks. So we have this chunks attribute, which is a list of documents. And each chunk can consist itself of chunks that you can go down the road here as far as you want. But you can also go sidewise, because on each level, the documents can also have matches. So like this chunk could be similar to another chunk on the same level, or chunk could be similar to another chunk on the same level from another root document, just to recall. Something we introduced in 2.0 is the document array structure. And it's basically, you can think of an array of documents. It's really what it sounds like. But it's a bit more. It has all these methods you would expect from a good, handy data structure. You can insert, append, and also clear. You can even sort the array, but it's more. It's also, you can save. Oops, this spoiler. You can save the whole document array and load it. So we have this slide here on the side. You can just initialize your document array like this. You specify the documents here and have as an array, and initialize the document array here. And then you just call document array.save. And in this example, we choose a JSON file to store it. And it can be really handy for rapid prototyping, because then the file is on the disk and you can just look into the file, look at your data, and then see for debugging purpose how it works. If you want to be more going through the production side, and in particular want to be like 10 times faster, then you can also use the binary format to save all your data very efficient in a binary file, and then load it in the same way. So like this is something special about the document array. And also we have advanced getters. So for instance, when you have a document array, but you just want to get all the document IDs, then you can just call document array dot get attributes and then hand over the ID parameter and just get a list of all the IDs. So really handy. And this was missing in 2.0, or it's really improving the development when you have these methods. And also we have traverse flat, which is really powerful. Just to recall this document structure, you can specify here a path where you would like to iterate over your documents. Because like maybe your executor would like to make a change on the chunk match level. And then you would have to go manually through document.chunks and make a for loop through the chunks, and then consider the chunks of the chunks, make another for loop. And it's like for every executor, this would be just too much work. So we developed this traverse flat method where you just specify your path in a way like CCM, which means chunk match, and then only traverse through these matches and only change attributes in these specific documents. And traverse function is similar, but then you get like a list of these matches, and this traverse flat, it's flattening it. So you can just try it out. It's better than me explaining it. Next thing, executor. On high level, what an executor is we have these code blocks where you can insert your custom code. Then it emits some documents, goes into next executor, processes, emits documents, and so on until your calculation is done. So this is where executors are used. It's so from your perspective, it's really like this. In the background, we're doing much more, providing all the infrastructure, letting it run everywhere, whenever you want, and yeah, but it's just high-level abstraction. And executor looks like this. You define your request endpoint. So you define on what endpoint you would like to receive messages from this function. And then whenever someone is calling this endpoint, this function is getting executed. And of course, you inherit from the executor base class. And here are the possible parameters you can put into your function. And you don't have to put all of them, but you can access the docs as described before. And you can also add additional parameters just as a dictionary to have full control. So we don't want to limit you in some way. If you think documents are not enough, you can also have a parameters dictionary. And then we have this docs matrix, which is a list of document arrays. And to illustrate what that means is, okay, it's a bit out of screen, but here's written executor. In this case, where we have two executors sending docs to one executor, then this executor is not just receiving a list of docs, because then you don't know anymore which doc comes from which executor. Maybe we want to handle them differently. So what we have here is a list of document arrays. So for each executor, one document array, which is basically a matrix, list of lists. And yeah, same with the ground truths for evaluation. Then executor from YAML. It's also possible now to have inline YAML and load your executor from there and basically specify the same attributes you would specify in Python code, specify as YAML. I go quickly over this.
No,
because,
can you go one back?
Okay.
There's one important distinction I want to. So what you see here is that there's this requests. In the executor itself, there is no add requests decorator. And this somehow is mapped in the YAML. So you can, when you have executors and use executors on someone else, want to map the endpoints somehow differently, you can also change the endpoint mapping via YAML, which is pretty handy when you have custom code, multiple flows that somehow deal with code and you want different endpoints and name the different endpoints differently, then you can use this.
True, that's a very good thing to point out. Now going to the flow. Here's our flow API. We can construct flows by adding executors and also using the needs method to then specify which executor has which dependencies. So before you have seen there are executors in parallel. So with the needs, we can define which executor does this one need as input. Also, there is still the flow, the context manager to make sure that your flow is properly started and also closed after program execution. So no instance is just running, idling around or something. We have the plot function to visualize the flow, very handy for debugging. And here is the send request method, which is a post method. And previously, we just had index, search, update, delete, index array, and the array, and a couple of more, but basically predefined methods to work on the data. And now you can post to whatever endpoint you want and can define whatever endpoint you want. And I can say from development experience, it's much more fun, much more enjoyable. If you're not limited, you can do whatever you want there. Here are also the control type. You can block your flow and use it as gRPC or REST gateway. Here's actually an example also where we do this. So first, we just define our executor here, our endpoint, and then send documents to that endpoint we defined here. So this is here, the flow context is created, and within the flow context, we can now send our request. And this just simple minimum working example, we just send an empty document just for illustration purpose. And now, so after this line, like the flow context is left. So it means the context manager makes sure all the instances used are freed up and all the processes are stopped. And most of the cases, especially when you have a live system serving queries, then you don't want to just make one request and then shut it down. What you want to do instead is calling flow.block, which just says, stop here. We never leave the flow context again. And we start here on this port, 1, 2, 3, 4, 5. Start a REST server or a gRPC server in this case. And we just wait here for client requests. We also developed a client package which can be easily used, where you define the same port number, and then the client is connecting to the server application. And you can even run multiple clients of this and then have async calls to the server application. So this is the common way of using it. Yep, flows can also be defined by YAMLs. And here in this example, we just defined one executor, so specifying the name of the executor. Sorry. Yeah, yesterday was fun. Defining the name of the executor. And we can also provide a full list of executors here. So just for illustration purpose, here is just one, but it can go down like, yeah, adding how many you want to have. And then you load your flow, this time not creating a new flow instance and depending the executors, but loading it from the YAML file directory. And then you send your requests as you used to. Now, to the part where all of you waited for. What does 2.0 give us? So more flexibility, more control to the framework user, simpler to get started for beginners. So before there was a threshold, like first you have to learn about drivers and so on. And now you can easily get started. Then you have this custom request type I talked about. It's in general more Pythonic way of writing it, more explicit and less implicit. So you don't have to learn that much before getting started. And personally, I can say much more fun developing. So just to illustrate here what I mean by simpler. So before it was like this, you have this executor and it has some drivers as attribute. And whenever a message comes in, it checks are there drivers related to this message, then the related drivers are executed, and the drivers magically knows about the functions the executor have, and then call the executor function and return the documents. Yeah, back then this totally made sense. Here you have it's just a copy of that one, so it happens exactly the same. But now to simplify the usage, at least from outside, from your perspective, now it looks like this. Just have your executors and have your documents flowing through the flow. So here are a summary of executor changes. So we still have our save config, load config, close method when the flow context is closed. Also have our workspace, even though it's refactored. Some small changes to the meters. And here the important part is the drivers are removed, and yeah, now you use the requests annotation to link the related functions. Then important thing, the save method is gone. So there, for each case, for each executor, you might want to save different things, and you can, whenever you close your context, close method is called, you can decide, yeah, is it even a stateful executor? In a lot of cases, it's not. But if you have to needs to persist some state, then you can make this in the close method. And there are also other things to mention, like the pickle interface. We don't pickle the executor anymore. This was also a cause of quite some errors, because then you sometimes have some open file streams which cannot be pickled and so on. So like always pickling every executor, even if it's not necessary, yeah, it's a too broad assumption for all those cases which are different. So giving the developer more freedom instead of making assumptions on what they're doing. Yeah, pre-init, post-init is not required. You can, if you want, if you have some heavy processing done to be done, then you can also create your own pre-init endpoint or so, but it's not a boilerplate code anymore. Exactly. Also, the inline import is also removed. Before we had a lot of functions where we did the import within the functions, and this is also now cleaned up. So coming to the examples, now it's getting more feasible. Here's one interesting example from Han, migration from 1.x to 2.0. Just for you, now you don't have to fully understand like a lot of code, a lot of text. You don't expect you to read all of this, but just to get a feeling, okay, it's some changes, but it's not like, oh, I could never do this. But now let's go through an example a bit more in detail to see what exactly changes. So here we have YAML configuration for the binary PB indexer and in 1.x. And as we did before, May
I interrupt for a second, just to give some more context? So what Florian is now showing is actually what we did for a lot of our experience when we converted our examples from 1.x to 2.x, or when we somehow converted parts for our customers somehow from 1.x to 2.x. So this is how we perceived it and what we did. And it's not just a toy example, it's really things that we did here now. And I just want to,
that's
raise
a
this awareness for
yes,
this.
Yes, that's a very good point to underline the importance of this, because yeah, that's from a real world example actually. And what we did here before was having this YAML file, which yeah, at some point for us, we don't work on a daily basis with this, so we understood what this means, but for newcomers, very hard to understand. So I highlight some parts of this in different colors, and you will see in a minute why I choose these colors. So we have our requests attribute here, and then we define search request and index request, update request endpoint. And each of these endpoints has different drivers which are applied. And yeah, you just have to know that you have to use this driver. Otherwise, so just from logical thinking, you cannot find out why this driver has to be used. And then, so you have this YAML configuration, but you also have a class here defined with a method, in this case, add. And just somehow in the background, by choosing the correct driver, it was decided that the add function is called when making an index request. And the index, the vector index driver was calling this add function. So you just had to know this basically, or look it up into the code. And yeah, the indexing worked like this. You called f.index. So this only worked with index. So these possible request type, they are limited. We just had like index, update, search, and delete. And adding some new request type would have been a change to the core, which cannot be done for custom use cases. Okay, so the same names have the same color here. Now let's go to the 2.0 example to see where to compare both of these. And so like the YAML definition is much simpler. We don't have to provide all the requests. So what I was missing is here, we also have to configure the meters, of course. It's just missing here in this illustration. But you don't have to provide the requests in the YAML configuration. So instead, the request, so here, this box here, is done as an annotation. And you specify the path, so like shown here, the yellow color, just as a string instead of knowing the right request type to choose. Like this is a yellow one is an index request type, and the pink one is the update. So this is matching with each other. And analog, it's the same with search. So this is a search request. And now it's just the search string here, showing this endpoint. And yeah, before you were calling this fixed function of f.index. And so it was just there and you had to know it. And now you call this exact path, which is specified here. And you can just know it for see it from what you said there, and it has to match what you said here. And there's even a shortcut, some syntactic sugar, where you also can call f.index now on this, and then it will use this, make this work in the background. So, but yeah, just for illustration purpose. Is something you want to add here, Max?
Nope, I'm good.
Because everyone, that's also a reason why we want to do this together, because everyone has a bit of different experience with 2.0, and things like different things are most valuable for everyone. Okay. So yeah, we have this one predefined request type versus any kind of requests here. Then to recall, here are the drivers. They are gone. And the functionality of the drivers, you can just write into this function here. So when, like here, this exclude QL or something, you could also drop these attributes if you don't want to have them explicitly here. And whatever in the add function was before, called by the vector index driver. It's even hard to explain when you, so that's where you see it's not much simpler. And you can have this functionality directly explicit here and don't have this magic then in the background. Yep, explicit function call versus implicit function call by your drivers. And something else. Yeah, exactly. Because something was missing until now, the traversal path. Here we could specify, like for search requests, where do we want to search? Do we want to search on root level? No. In this case, we want to search on the chunk level. And then we want to exclude something on the chunk match level and on the chunk level. So this configuration, it's not gone. It can now be done like this. You get this document attribute in your function here, and then can do doc traverse flat on the chunk level. And you get all the documents on the chunk level, can loop over them, process, do processing, and change attributes, append something, whatever. Okay.
One comment from my side here, when Florian always said you can adjust it, the nice thing is now these classes, since they only inherit from the executor and always get docs, so the interface of these search index functions is always the same, what was he introduced at the very beginning, and you want to somehow add more functionality. So let's say you want to use this indexing, but somehow for an index, you want, for the binary B indexer, you want to filter beforehand or just throw away some parts. You can wrap the executor that you can with your own class and have another executor just as an object in your own class. And then write the custom code around calling the executor that you wrap. And this allows you to do more or less everything custom, and you don't need to know which drivers you need to know. So you don't do this via YAML anymore. Before, you would have done this by YAML, adding more drivers and then choosing exactly the right driver to do things. And now you do it by wrapping an executor and writing a custom code around this executor.
Yeah.
This is much more Pythonic. You directly have the objects in your hands, and you can do docs.filter and so on. And all these functions Florian explained beforehand, now you can use directly on the document and really change the data as you want to change it.
Yes, especially good for debugging, and yeah, most of the development is debugging, so really useful. So now just a little bit about dependencies. What we have had before is the core development of our product, and then you could, like, yeah, there are a lot of encoders, a lot of machine learning models, and we cannot put all of them in the core because not everyone wants to use all of them at the same time. So they are in different repository. They were in different repository. Same for indexes, segmenters, crafters, rankers. So, but now with 2.0, it is a bit different because, like, yeah, also having all the one repository is also not such a good solution. So we have them now as different repositories, so just one repository for the indexes, and more to go here. So stay tuned, what we will announce soon about this. And yeah, so most of the code examples I showed you are actually from the wonderful cookbook Han designed. And I would like to encourage you trying it out, going through all these code books. And when you do this, you become really experienced, I would say, already in 2.0. And yeah, please do this. This helped me a lot, understanding it and then using it for the client cases. Yep, this presentation is done. Get in touch with us. Join all our channels or our social media.
Yep, we would love for all of you to come join us on Slack, become part of our community. And as I mentioned before, we've got the meme competition, so join it. Share your memes on Slack and Twitter, and you got to be in it to win it. It being the awesome swag and the 3D printed medals. So yeah, if you want to see some of the other memes, all the ones I put in the presentation and more besides, they're all on our Slack on the general channel. So yeah, you can head over there. And if you want to join, instructions are on jina.ai/blog. And yeah, shall we open it up to questions? So I see a couple of new, well, I don't want to say faces. I see a couple of new profile names in the participants list. So we've got Vangelis and Winston. You guys want to introduce yourselves?
Sure. Hello. My name is Vangelis. I'm a very recent, actually, user of Jina. I started, I think, about 3 weeks ago. I dropped the project for about a week, and then when I came back to the documentation, I saw that Jina 2.0 was released. So it was a bit of a shocker. But yeah, I think it's very useful. Thank you for the walkthrough. I think it's becoming much more smooth. And since I was a very junior user, it was indeed it was a heck of a ride to get to know the drivers and understand what's happening. I think this is a very good move from you.
We took great joy in killing those drivers off. I think I speak for all of us. What kind of project are you building, Vangelis?
I'm mostly getting to know the infrastructure of Jina. I work as a machine learning engineer in Workable. So I'm trying to understand the capabilities to see if we can apply it internally.
Oh, nice. What kind of data would you be searching?
We are in the hiring domain. So we would be searching jobs, candidates, interview questions, things like that.
Oh, nice. Yeah, a multimodal PDF example might come in useful if you're searching CVs. I nearly said CSVs. I've been working with them all day. But if you need to search through CVs that are coming into your system.
Yeah. I saw the example. There are many capabilities for sure.
Yeah, stay tuned on the PDF search front. We've got something nice cooking.
Good. And wait.
Good stuff. And Winston?
Hello, my name is Winston. I'm going to be joining Jina in July as a backend engineer, so I thought it would be great to join this engineering all hands to get to know Jina 2.0 a little bit more.
Nice. Always good to have more people on the team. Cool. I guess not much in the way of questions from people today. Any of the engineers have anything they want to share? Wow, nobody's going to say, yay, I'm so excited for 2.0.
I'm very excited for 2.0. Yes.
I think
Okay.
everyone's recovering today, all the Berlin team. That's why the videos are off.
It's okay. It's quite good.
All right. Yeah, in that case, I guess we can wrap this up for the day. And it'd be great to see all of our lovely community members on Slack, and we can chat to you more there. Right. Thanks, everybody.
Ciao,
Thank you
guys.
very much.
Thank you.
Bye.
Bye bye.
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 Ciao.
Bye.